a lot of fun. Again, for the final project, a couple of people had asked me. Um, the idea is you'll get together with three people because everyone doing it individually is too slow. We want it to be a small little group project here and come up with something that's probably about a 90-hour project. Again, just a rough ballpark estimate here for spending the last month of class on it here across three people working, I don't know, 10-ish hours a week or so. Probably a little bit less than 10, right? Because we got a little bit of class, but um, something that sounds fun that uses a popular Python library. So I'll talk about a couple different ones in the last couple weeks here. Any Python library you're interested in that you want to pitch a project on with your team and just explore it, do something cool with it, I'm up for it. So lots of different options we've got there. If you want to get into machine learning stuff, there's cool machine learning stuff. You can do some data analysis. We got lots of cool visualization tools. We got some cool web tools. We got some cool graphical user interface tools. Really, anything that sounds fun in Python, you can do a project on. Um, so you'll pitch the idea to me, make sure it sounds like it's about the right size. A couple of people last year tried to do something too big. I was like, just scale it back a little bit. That's cool, but focus on some core stuff first. A couple of people pitched a project that was like, I think that like something you could do in a couple days. Let's do it a little better. Was all. Um, so something like that is what we're going to work on for the last while for class. And it should be a lot of fun. Hopefully, something you can add to your portfolio and something cool you can talk about when you go out and interview. That's really the interesting stuff is when you can talk about something interesting you did that is not something everybody does. I don't care about the traveling salesman algorithm. Like literally everybody who takes the data structures algorithm class does one. I don't care if you did it. That's not fun. But doing a unique project where you had challenges, you had to go learn stuff, you had to go solve your own problems, that's pretty cool, right? And if you are interested in it, hopefully it'll be much more interesting for you to talk about. It's pretty easy to tell when people did projects that are boring and dull, and they're like, "Oh yeah, I had to do this," versus "Yeah, I got to go play with some cool stuff and learn some cool things." Um, so that's the goal for that one. So we'll finish out our chapters from the textbook. We get to the midterm here. Um, Again, the goal for the midterm is it's easy. It's just a quick sanity check. Yeah, you've got through all the text. You can go find that information, do something with it. Right? It's not meant to be hard, just a quick check in for the midterm, and we can go from there. So let me pull up our last project here. I want to get to unit testing first, and we'll see how far we get with that. We take a good chunk of today. We'll see. Oh, I reset. That was wrong. There we go. Oh, I don't even want that one. We did our classes, right? Where did I put it? All right, we'll go open it the hard way. Documents, GitHub. That's the wrong documents. There we go. 298. Classes, there it is. Right. So all of the things we've done so far, when we make sure that our classes do the things that they're supposed to do, the only way we've been able to check that is by throwing something in main and saying, okay, if I set these lengths here, what is the area? And okay, I know if it's a 3, 4, 5 triangle, the area should be 12. We hit run and we look at it and say, okay, or 6. I can't, sorry, 1/2 base times height. Um, right? I have to go look at it. I have to see the output. I have to make sure it's right, do all those sorts of things. And that gets to be tedious, right? And I don't know if you've ever written an English paper, right? It's really hard to proofread your own work because you know what it's supposed to say. Thankfully, that's getting a little easier to have the computer help us with that, but proofing is hard. So a tool that's really good at comparing output and saying, okay, if a 2 should come out, did I actually get a 2, is a computer. So what we get to do is we get to write code that tests our code. Seems a little silly to write more code, but that's what we're learning. That's what we're good at. Ideally, right? We're good at writing code here. And then we can build out a unit test library. So we can run all of the unit tests every time we change something to make sure that the thing we changed didn't break any expected functionality. Right? With small little projects, not all that hard here, but as things get bigger and bigger and bigger, we work on group projects and team projects, and you've got, tens of thousands of lines of code, hundreds of thousands of lines of code here. You want to know that you didn't break anything when we're going to make changes. Because again, most of our code lives in this sort of maintenance phase, right? It costs companies lots of money to pay developers because it costs a lot of money, right? There's not everybody can do it, that sort of thing. So they want to get as much money out of their software as they can, so they keep using it for as long as possible. And occasionally things have to be changed, right? Oh, we have to go tweak it. We have to maintain the software here to keep it up and running here. It's a lot cheaper to maintain software than it is to write brand new software, right? That's why people still hire COBOL developers. Just blows my mind. Like that was dead when I was in school 20 years ago, and it's still kicking. So um, we want to know that as we're maintaining our software, we didn't break anything. So if we build out a library of unit tests, we can run them every time something changed and make sure we didn't break any core functionality. So we've got some cool tools in PyCharm to do that in Python, some cool built-in libraries. So what we're gonna go to our shapes class here, and let's look at, say, we'll do rectangle first. And we can do class by class by class. Again, the lowest level testing here, our unit testing, tests one small bit at a time, generally one function at a time, right? I want to know, does the set length function work? Does the get area function work? I can test one at a time. Now, we're going to be a little bit lazy and combine some of these things because as we go and set them, we can then test it. Did we get the area back out, right? It's not super strictly one function at a time, but we're testing one little bit of functionality here with the get area. To do that, we have to go set some other things. That's all. So we're going to right click on it and say go to test. And PyCharm says, you don't have any tests. Do you want some tests? You say, yes, I want some tests, please. So, okay, what do you want to test? It's going to make a new file called test shapes. It will come up with a class for us. We're testing the rectangle class, and you can check which of these functions do we want to test. Again, we might as well test them all, right? Again, I'll show you let's spend a lot of time testing every single little thing here, which is good, right? Any code we write should be tested, because if you don't care if it works right, why'd you write it in the first place? Right? If it was worth writing, it's worth testing to make sure we did it right here. So we want to test all those functions, and we get some cool boilerplate code here. Now, there's a lot of different ways to write tests. I'm very partial to a convention we call the AAA convention. Lots of people like doing it. It's just a convention. You don't have to. It's not a rule. But if everybody does it, then it makes it really easy for us to go read other people's unit tests. So we get our class that inherits from the test case class from the unit test module. It's all built into Python here. And then we write one function at a time here, testing those other functions, right? And it gives us self-fail, which is not a good thing here, but that's okay. So we go run our tests here. We get a bunch of failures. We get a cool test explorer window now that says, hey, in this module, in this class, these functions failed. And we get these nice orange X's. They're not even really red. They're like orange X's at this point here. That's okay. And our goal is to turn the orange X's into green check marks, right? That's how we make this thing work. And ideally by actually testing our code, right? We don't want to cheat it here. There's silly ways to cheat, but that's okay. So the AAA convention stands for arrange, where we set up the variables we need. And then we act, we call the code we're testing. And then we assert. Did we get what we expected? Right? So we don't want the fail here. So to set up the variables we need. So for testing set side length, we need a polygon and we need a side that we're setting, right? And we know that setting lengths should set both lengths, either lengths, and setting width should set both widths, or I guess it's just one width, sorry. Right, either the 1 or the 3 will set both, and setting the 0 or the 2 would set both, right? So we should have a value that we expect to get back, go and set it, and then when we go call our code, we'll actually go set it, and then get our values, right? Did it actually change here? So we'll have our rectangle, oh, then we got to go import curses.textpad. I don't know what that is. That's probably not the rectangle we want, though. Don't know that. So from shapes, you can import rectangle. Let's try that again now. So we want our rectangle equal to rectangle. And now our rectangle class, we added our init. You have to take a length and a width. So let's give it 0 and 0 to start. Right, let's give it nothings to start here. And then we go and have an expected length. Expected length we'll say is 5, and an expected width is 10. And now we're setting individual side lengths here, right? So we want to individually set the 0 and individually set the 1. Right? We could go crazy and do a test where we're setting 0 and a test where we're setting 2. Sure. Um, I'm not super concerned about it here. If you want to go nuts, you can. But we know, hey, if we're just dividing by 2, that's going to work the same, right? No matter which one we give it. So we're not really testing other bits of code by testing a 0 and a 2, because this exact same function will run the same way either way. Um, so we'll just try it once here. So if we start with 0, 0 here, we've got what we expect to have happen, right? Now let's actually go call some code. So we'll say rectangle.set side length. We'll give it the expected length, and then the index will be 0, 0 for the lengths, right? And then we'll do the set side lengths for the expected width here. Let's give that 1. So we set them both. Then we need to get the values back out, right? So we changed them. Now let's go ask the rectangle, hey, what do you think your values are? Right? What are you currently storing? So we'll have an actual, I don't know, side 0 is my rectangle dot get side length for 0. An actual side 1, my rectangle get, let's copy paste this one here for 1, and then 2 and 3. I'm going to check all 4 here just to make sure they all set properly. 2 and 3, 2 and 3. Right? So call the code we're testing, and then go get our values back out. Get what the values actually are here, and then let's assert, did we get what we were expecting? So this is from the module itself here. So it's self.assert equal. There's a couple different ones you can use, right? So a bunch of different asserts, greater than, less than, is none, a whole bunch of cool things you can do here. Basic, quick, easy test. We're just checking, does the value match this, right? Is it equal here? And we don't need to get anything super complex here. So then we give it the expected length then, and my actual side 0, right? We set it to the length. It should be the length. And we do the same for actual side 2, right? And then we've got our expected widths. So assert the expected widths for the actual side 1 and the actual side 3. And it's going to check all 4 of them. Do they actually match here? Right? And that's our unit test. Did it do what we expected it to do? And I don't have to look at the console out. Right? We can write code to go test that for us. We can go run our test here. Uh-oh. And it's failing. Let's see. Oh, invalid 0 is an invalid starter length. I'm sorry, I forgot. We can give it 1 and 1. We wanted to try and obey some laws of physics, right? You can't have a 0 length. And now we get a green check mark. So we feel pretty good that set side length is doing the things that it's supposed to do, right? Now, there's fancier ways of doing unit tests, and I'm pretty sure if you pay for the premium version of PyCharm, it'll give you this thing called a code coverage metric, just a way to measure how much of our code is actually running when our unit tests run. Call it our code coverage. How much of the code is being covered by the tests, right? The goal is 100%. Again, any code that's worth writing should be worth testing. It's sometimes really hard to get every single little tiny bit here. Every if, every else, every switch, every case that you have here, whatever it happens to be, can be a little bit tough, right? So, in the world of business where we get paid to do things, it takes our time, energy, and effort to write our unit tests. And at some point, employers say, 75% is probably good enough. And you're like, oh, okay, sure, right? You sign my paycheck, I'll just smile and nod. Right? Ideally, we test it all, but at some point, we just don't have unlimited time to do things. So we'll just get as close as we can to get the core stuff tested and live with it. Right? It's not the end of the world. It's okay. It's a business decision. It's a trade-off. But with code coverage, it's saying, okay, did this block of code run here? If we never tested an odd number, we don't have 100% code coverage for this function, right? But we've tested an even number, so we know where this one runs. We tested an odd number, we know this one runs. So we're just eyeballing it here. But again, there's fancy tools that will actually measure that for you, and premium versions of stuff. We're just doing the free stuff. So for the other ones, right, setting length, setting width, there's just one-liners here. In areas of one-liner works pretty well. So for other tests, then we can do the exact same thing here. Just make it a little bit shorter. So for setting length, then, right, we only care about the lengths here. So I don't need the other ones here. I don't need the 1s and 3s. Or if we wanted, we could test that they didn't change if we so cared. Again, we know it's only changing one thing. So you can go crazy testing your stuff if you want here, but it's okay. So instead of set side length, we'll say set length here, and we'll just give it the expected length. And if we don't change the widths, they'll stay at 1. We can test that they're 1, or we just ignore the widths. It's probably fine to just ignore them here, right? So did 0 and 2 change? Did they actually change? Right? So make a rectangle, started at 1, 1, try changing to length of 5, did it change? Right? And this one hopefully should pass now. Cool, that one passes. And again, we'll do the same for set width. I guess I'll go back to this one here because we have all the widths. So some of these tests are sadly kind of boilerplate. We copy paste a bunch here. These are not the interesting things here to test sets and gets, right? The interesting stuff is, does our code that's doing cool stuff actually working here, right? But again, we got to start kind of small as we go. So we'll have a width there. We'll test our width here. Set the width to the expected width. And then we'll test, check 1 and 3. Did those ones match, right? And then for an area here, great, we can just make a rectangle and get an area. Uh, you don't have to do quite so much here. So we make it of, I don't know, 4 by 8 or something, right? And we'll have an expected area. Then it should be 32. So for act, then all we have to do is get the actual area, right? There's no other code we're testing. We're just testing the get area. The actual area is my rectangle.get area. Rectangle.get area. And then to assert, self.assert equals my expected area, my actual area. Right, and then we run all of our tests here again. I think we can just do rerun all. Is that? No, I want all of them here. There we go. And because this is code that we're running, if it's not working here, right? If I typoed this here or something, or we get a bug and something's not doing what we expect it to do here, we can debug our tests. So you can say, okay, hey, let's put this in debug mode here. And when I want to go do my tests instead of run, I can say, let's debug the tests, and we get debug mode. I don't need to go write a whole main function that just gets some user input here. I can go get it right here and debug it from here, which is really cool. So again, a lot of the code we're going to write gets away from having the user type something into the console, right? I don't know if you guys ever used a console-based program before in your life, before you got into computer science school. Ever? No. People just don't do that very often, right? Most of our tools are graphical, or their websites, or other sorts of things. So writing tests for code need to work with things that don't deal with the user input. Right? So when we design our solutions, again, we want our classes to be these nice little compact pieces. We're going to encapsulate all of our details, work with them abstractly. I'm going to test my public functions. Do the functions do what I'm telling people they're supposed to do? That's the important stuff to test, right? You could go nuts and test some of your private functions, but again, they're probably getting used in the public functions. So if the public function does what it's supposed to do, you probably feel pretty good your private function worked, right? And we don't need to go and test and break any of those barriers and try and look into the stuff we don't need to look into, right? No one else has access to the private functions, so we probably don't need to go test them individually, right? We're testing the bigger pieces, right? So this is our way of getting all of our tests up and running. Now, getting a good suite of tests then enables other really cool things we can do with software. Now, again, this is just unit tests. There's other levels of testing. You probably talked about in your software classes here. You can do integration testing. You can do system testing, end-to-end testing, all sorts of other levels here. Right? This is just the basics. But once we can start writing code to write tests, we can make our code more interesting. Right? We can make it more complex, do more cool things here. The next thing we want to do is, if we have tests, then we can run continuous integration tests. So as code is integrated into our code base via source control tool, we can run the tests. Now, the larger our code gets, the more tests we have, the longer that's going to take. And you probably don't want to pay your developers to sit around for half an hour staring at their screen while it does nothing, right? So let's make someone else's computer do it, right? Let's do it on the cloud. So GitHub, again, other tools will do this sort of thing as well here, offers continuous integration testing connections. So this whole GitHub Actions piece here is the thing that they sell for that. As code gets changed, so in the VS Code code base here, this 147,000 commits, every time a commit is made here, it goes and triggers the unit tests, or all of the tests, or some suite of tests, again, that you can customize this thing up the wazoo here. It's pretty cool. So, hey, 29 out of 30 tests have run. They're currently running the 30th test. We're waiting for results here. Oops, one of those tests failed. 29 out of 30 ran, but it looks like some failures. 17 out of 18. There's some failures here. Here's a good one. 31 out of 31 passed when whatever this commit happened here, right? So you can go and look and see everything that's passing here. Again, this is other cool stuff GitHub offers, but now we can have continuous integration testing because as our code changes, we can go run tests on someone else's computer in the cloud and make that go run the test to figure out if it works or not, right? That's pretty cool. So I don't have any choice to not run the tests because when I make my commit, all the tests go run. It's not like I can forget, right, this sort of thing here. So we've got a cool system in place to automate all of the tests as well, which is really handy. And then depending on your product, again, the next cool thing you can do, if you have continuous integration tests running and you feel like your tests are covering enough of your code that you feel comfortable deploying your code, you can do continuous deployment. So you can take code, okay, if it passed all my tests, now let's go push it out. Again, more of these cool automation tools, this sort of like DevOpsy idea here. And it doesn't work for every single product, but a lot of products work nowadays like that. They'll update themselves, or if it's a website, you can go update your website, do some fun stuff. You can go deploy it automatically. We don't need to have some sort of manual process like, oh, hey, let me go send it off to somebody. They can go install it. Let me go tell them to do these sorts of things. We'll just update it. Life is good. You know, that's useful because the shorter we can get that time frame down, that lag down between, oh, someone has an idea here, someone has to go code it, test it, run it, deploy it, whatever, and then someone can go figure out, did it do what I wanted it to do here? It's good, right? We want to avoid that lag that says, oh, someone told me to do this 3 months ago. It took me 3 months to get it in their hands for them to go test here. It slows down that development cycle, right? Because a lot of times we don't really get the good first answer the first time here. Um, oh, I've got a funny comic I want to show you here, but it's in my WhatsApp. Give me 1 second. I'm going to pause this. All right, I found this comic the other day. I sent it to some of my coworkers here because we're nerds and we think this sort of stuff is funny. So I don't know how well you can see that with the text here. So this little ladder swing is how the customer explained it. I think, can I zoom that in? There we go. That's a little better. How the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how it was documented, what operations installed, how the customer was billed, how it was supported, and what the customer really needed. So we joke about it here, but this happens all the time, right? It's hard to communicate needs in a complex environment a lot of times, right? Sure, even a tire swing. That's a swing. It's hard to communicate sometimes. So the shorter time we can get between someone telling us we need to change our software to do something and us getting it back into their hands, the more productive we can be, right? And we call that some sort of business competitive advantage, these sorts of things here, which is cool. So if we can get our tooling to run our tests and be like, okay, we have enough tests, we feel good that it didn't break anything here, I can go update my software live, done. We go do it. Now it's super easy for web products. Here, other products, you trigger an auto update, that sort of thing here. There's all sorts of different release cycles and things you can do to say how often we want to update our software. Sure, lots of cool things we can get into. DevOps was one of the fun things I like to do. Endless possibilities, really. As much time as you want to put into it, you can automate really cool things, which is really fun. So getting our tests up and running there is pretty good. Now, what gets hard to do here with our tests, now this is a little bit crazy here, but when we're dealing with dependencies, we run into all sorts of issues. Now, with our shapes here, we're not dependent on any other libraries. We're not dependent on any other functions here. But if we were, it'd be hard to test it independent of that other library, right? Now, a really simple, easy example here we'll look at is just random number generators. Right? It's really hard to test something that's based on random number generators because if we did it right, it should be picking a new pseudo random seed every single time and look like random numbers, and I've got no way of testing that. Right? It's just not going to work very well. So let's just add a new module here real quick. Let's go. I'll call this guess. So we're going to a class for guess here, define an init, and it has a self.number is, and now in here we'll import random, and then we'll say randint 1 to Doesn't need to matter too much here. And then we'll have a guess is 0, and we're going to track how often someone takes to guess our number here. Not very interesting here, but that's okay. We'll have a guess and give it a number. So then we'll take our self.guesses plus 1, and then if my number is equal to the self.number, return true. Right? That's it. What is it? Oh, it doesn't see another return. Otherwise, we return false. That's it. That's all we do. So every time we guess, pick another one, pick another one, pick another one. But to do this now, we have a random number. So I can't really check, am I counting my guesses correctly here? Right? I guess we need a way to get that back out. So let's have a define get number of guesses. Sure. And we can return self.number of guesses. Right? I can't test, is it incrementing this very well because I don't know what the random number is going to be. I'm dependent on another library here. So it's going to be really hard for me to test this. So what we can do is it's this fun technical term here. Let's see, I think there's a good Wikipedia page for it. Dependency inversion. So we want to invert our dependencies here. And you can read all about it. It's good stuff here. Because I can't test otherwise. So we're going to change how we're depending on these things here. So what we can do is we can pass in something that looks like random here. And I don't need to import random. You're going to give me something that is a random number generator here that has the function for randint here. Right? Seems kind of silly here. But in our live code, we can give it the actual random number generator. In our test code, we can give it a fake random number generator. Right? That's sort of the magic behind the scenes here. So if we go test this now, let's go to test, create a new test here. Yes, we want to test, get test guess. Sure, whatever here. And then from guess, import guess here. Now we need another class in here for our fake random number generator here. So fake random. And I'm bad at names here. That's okay. Don't worry too much about it here. Fine, init. So we don't even need an init now, right? All we really need is a randint that takes, I don't know, start and stop, end and beginning. It doesn't really matter, A and B. We're going to throw them away anyway, and we just return a 5. Every single time you call randint, we just return a 5. Oh yeah, maybe static. Yeah, let's make it static here. Sorry. So we don't need self. That's right. You don't need an instance. Oh goodness, did I do it wrong? What did I do wrong here? Make method static. Oh, with the tag. Okay, there we go. So it'll just always return a 5, no matter what. It's not random here. Every single time it's 5. So when I go and test my guess here, right, to arrange, act, and assert, we can make that guess here. So my guessing game or something, I don't know, guessing game is a new guess given my fake random. Right? When it is given fake random, it will call randint here, and get a value back. Always going to get back 5 every single time. Right? So we can give it this to always get a 5 back out here, and then we can call my guessing game.guess. We'll guess the number 5 here, and then we have our actual number of guesses. It should be 1. It should take us 1 guess here, and then this should give us a true or false here, so we can have a result, right? And then we can say self.assert. Now this one we can say assert true. Assert true is my result. Right? You could say equals result and a Boolean true. Sure, it's just a little bit more typing that way here. And then our actual number of guesses, expected guesses, is 1. Self.assert equal, my expected guesses, my actual guesses. Right? So now this test, hopefully it worked. Let's see. Look at that, it worked. Because we told it what the number was, right? By using our fake random number generator. When we actually wanted to go use it somewhere else, we just handed the actual instance of random, the actual random class, not my fake random class. And it does what it's supposed to do, right? So we're passing in the dependency so we can control that dependency. I think I came up with the wrong word here. I'm sorry. I think that's dependency dependency injection. I think look at that. It even knows we're doing Python. How weird is that? That's a little spooky, actually. That Copilot's like, oh, hey, you wanted this in Python specifically. Interesting. All right, yeah. So we're passing in the dependency. I'm sorry. Um, Inversion of control. That's why I'm getting my words mixed up here. I'm sorry. All sorts of untechnical terms here, but you just have to go Google every time, right? So pass that in. Now I can unit test something that depends on a different function or a different library, and I don't have any control over it. Right? But now I can still test it's my code doing what it's supposed to do, even if it depends on something else. We can just fake it. We can other terms, other libraries use the word mock. You would mock that dependency here. Just okay, here I'm going to give you these things back. And again, you can make these as complex as we need to. Maybe we want to get 5 different random numbers. Sure, we just tell it, hey, return a sequence of 5 random numbers. Right? Anything you want to do, we can control what it's going to give back here, which is really cool with our unit tests. Right? And again, we're going to get enough unit tests to get ideally 100% code coverage here. Because I'll definitely die on that hill. If you don't care if it works right, why did I write it in the first place? And if you care if it worked right, let me test it. Right? Because I don't trust myself. And I've been doing it for 20 years, and I still screw things up all the time. So I like my unit tests. Right? Now, even if we get 100% code coverage, it's still possible we screwed something up here, both in our code and our unit test. And we tested that we're doing the wrong thing and we're doing the wrong thing correctly. That happens. Right? We're not guaranteed to be bug free just because we have unit tests, but you can feel a whole lot more confident that it's doing what you think it should be doing, at least if you've got your unit tests. Right? We can still mess stuff up. That's okay. But it's good to have our suite of unit tests here. Give us a little bit more comfortability. We're a little more comfortable. Oh, I can't English today. I need more coffee. That our code should behave as proper. Okay. And then we don't have to go run a main every single time, give it a bunch of input, those sorts of things here. And it's great. All right, awesome. So that's our unit tests here. That being said, when we start working with databases, that gets to be hard to make an entire fake database class here to go and test, are we doing what we're supposed to be doing here? We're not going to write a lot of unit tests for a database project. In the real world, go and unit test stuff. But it's going to take us way more time, energy, and effort than we need to test our database stuff here. So we're just going to skip it. Okay. Let me fire up a new project here. Is this week 8 or 9? I don't remember how I counted these here. Okay. Recess was 8, so this is week 9 here for databases. This is week 9. All right. This is my favorite week here because interacting with databases is the coolest thing in the world because literally every piece of information is in a database somewhere. Right? If someone knows about it, it's in a database somewhere. Except maybe some weird dying languages that they've not cataloged here. But everything else, we're getting pretty close on getting into a database. Come on, load up. There we go. All right, let me grab Dr. Chuck's book here. We're just going to skim through some of his stuff, and then we'll get into some more fun things here. So, SQLite is our quick, dirty, portable version of a database here. It does the things we're going to need it to do. It's not a full-featured enterprise database. Right? It's a light version. Performs. It is a small little database. Does small little database things, but it's local. Right? Most of the time, we don't want to run your database server on your laptop. Right? You want it to be running on some server somewhere that's backed up and maintained and managed by someone else and is always on and those sorts of things. Right? In the real world, we've got real databases running on real database servers. That's a little bit more complex to install. Right? There's a quick, easy one we can get if you want to install XAMPP to get a MySQL database up and running. It goes pretty quick, but SQLite's fine for now. This gets to be a little bit harder to share with people. We can add our SQLite files to GitHub. It's kind of ugly and dirty because it's going to change every time we use it. That's not the end of the world, right? By default, I'm pretty sure those ones are blocked here with our git ignore. Let me go 298. Pretty sure they're ignored here. SQL, yeah, the SQLite files I think are all blocked here. Oh, that's SQLite 3. Maybe not. Is it .db? I think it's .db. Okay, so we might be able to get it in, which will be good. So that way we can add our files. So if we want to work with a team here, right? Again, give your final project team a trial run if you want. Great. We can do this one in groups of 3. I'm okay with that. Make sure that your partners actually do the things they said they're going to do. Right. It's a pretty good test for that here. If you want. If you want to do it individually, that's cool too. But you will do the final project in a group. So here's a good chance to go meet some people. I always have people email me saying, "Hey, I don't know how to find a group." I tell them, "Well, you should probably come to class and meet someone." Again, that's what it is. So we'll go from there. So if you're watching the video, show up, find someone in the group, pester your classmates here, get a group here. All right, so SQLite lets us set up database tables. Now, are you guys familiar with Excel? Is this a tool you've seen before, used before? So Excel gives us a table view, right? We get rows and we get columns, right? So we're going to start with this idea of rows and columns to talk about databases and relational databases, okay? So something we might have here, you might have a spreadsheet full of, we'll call this our people here, right? And then what we're going to do is we're going to define what the columns are. So what's going to be stored in each column? Maybe this will be the first name, right? And maybe this will be the last name. Sorry, my A key is still broken here. So sad. First name, last name, maybe you have like a phone number, maybe we have an email address. I don't know, whatever we want here, right? And then what we do is we start filling out these columns here with rows of data. So we define what's in it. The other cool things we can do with databases is you can pick distinct types here. Now, this is just all going to be text here, right? Phone number, if you want to store it as an integer, that's kind of funky. Most people don't do that, but you could, I guess. But again, that's probably all text here, right? But you make rows of data. So Eric Chinesky, numlock. No, there we go. Chines, umish.edu, right? And now we have one row of data here. Now, what's kind of cool with databases and object-oriented programming, we can sort of think of our tables here as objects, as a class, right? With a bunch of attributes, right? So if we had a class for person, we'd have an attribute for first name, attribute for last name, attribute for phone number, attribute for email, right? And I can make a bunch of different instances here by adding more rows or by making more instances in my code. So they often sort of match each other. They don't have to, but it works pretty well if they match each other here. And we can fill out more information here. We can have Bob Jones, whatever phone number here, and test, whatever. Start filling it out here. We'll make more instances. So I've got rows here, right? So every row is an instance of my data. Now, the next thing we want to do is say maybe we're tracking these people as maybe they're our customers, right? I want to know what they've ordered, right? So I'm going to add another sheet here. So maybe then if they're going to order things, we probably need to know what they're going to order. So we have any products here. Rename this our products sheet here. So for products, we probably have a name. Do we have price, a description or something? I don't know. Whatever we want to come up with here. Now, price is probably numeric. You probably don't want this one to be text because you probably want to do arithmetic, right? We like doing arithmetic with numbers, not with text here. But again, I don't know. We've got widget here. This one costs $2.50, and then sub widget. Whatever we wanted to come up with here, right? We've got information. So now, if Eric wants to order one of those widgets, we can have an order, right? So we're going to add a table here for order. Let's call this one the order table. Now, problem we're going to run into pretty quickly is I don't have a good way to uniquely identify Eric in the people table and the widget in the product table. Right? What we don't want to have happen, we don't want to have customer name, customer phone, customer email, right? Product name, product price, product description, right? You can see how this is going to get pretty ugly pretty quick, right? To have to duplicate all that information every single time. Right? Anytime we're duplicating information, we're at risk of screwing it up. Do you know who usually does like data entry stuff? Are they paid really well to do data entry? No, they're the lowest paid people, and they don't give AF, right? They don't care. They're just going to do whatever. So if they're not paid very well to care, they're not going to make sure the data gets entered very cleanly. And there's a pretty common saying when we talk about data, it's garbage in, garbage out. If you put garbage data in, you're going to get garbage back out. So you need good, clean data to work with. So what we want to do is we want to reference the other rows in the database. We want a way to reference these other ones here. This is what we call our relational databases. We're going to relate this to another entry in the database. I don't need to rewrite this entire person's info here. I'm just going to say, hey, it's the person over there. You already have all their info in that table. So to do that, we need a unique identifier for them. And our technical term for that is primary key. So we need to know what is their primary key that identifies them as a unique row in the table. Easiest way to do that is you just add a field called ID. I'm a big fan of ID fields. And databases do this all the time. We know these ID fields exist. They give you one that just automatically increments. Every time you add a person, it just adds a number. First person's number one, second person's number two, number three, number four. It'll take care of all that for you. You don't need to come up with your own unique identifiers. We could do that. Now, if you look at your UMIDs, you got a little UMID number on it here. Don't know if they're auto incrementing or not. They might be, they might not be, but that's your unique identifier in the system, right? We all have got a unique UMID. That's our unique identifier. So that could be our ID field, whether or not they come up with it or they just pick the next student gets the next one. I think that's probably how they do it here, right? That's our unique identifier. So for my order, then I don't need customer name, I don't need all this customer info here. I just need the customer ID. Right? You tell me what the ID is, and I can go look that up here. And we'll do the same with product. I don't need to know the details of the product. I can go look it up here. So, hey, customer number one wanted to order product number one here. Right? Let me go add another row here. This is our ID field number one. Right? Okay, this customer wanted this product. So we go reference them. This is how I go find them in the other table here. Now for order, what else do I need to know? Well, I probably need to know like the date it was ordered. I probably need to know if it was paid or not here. Whatever other things we want to know, that's fine here. Now, this is fine, but I'm only allowed to order one thing. Right? What if I wanted to order two products? Right? What if I had two, this is a gasket or something, I don't know, for $3 gasket, widgets, gaskets, whatever here. Right? How do I order another something? Well, I only have a place to put a single ID. You don't want to put more pieces of information in a single field. That can be really ugly really fast here. It breaks all sorts of bad database principles. Go take a database class. You do all sorts of other fun stuff here. But it doesn't really work out well for us here. So what we then need is we need an order detail or order item here that rolls up to here's the order. It has some number of items within that. So we're adding another detail page here. So I don't need a product ID here, right? I need an order ID, right? This will just be our ID field for the order. And then I can add another table here for order item or order detail. Again, whatever you want to call it here is fine here. So this will be just as regular ID. Again, everything should get a unique identifier. That's how I like to do things. Other people design databases differently. That's okay. It's not the end of the world. It needs to know the order ID, right? And then this one can have the product ID. It can have the quantity. Now, this one's actually really important that you have price here because if you're in business long enough, your prices will change unless you're Arizona iced tea. Everybody other than Arizona iced tea changes their prices. I don't know how that works for them, but sure. So if you change your price in your products table and you didn't track what it costs when they bought it here, our arithmetic's not going to match. And you're going to think people owe you a bunch of money, and then your customers are going to be mad. Right? So we're going to duplicate that piece of information here because it's the price at the time they bought it. Right? Not the price that it's currently listed at in the catalog. That's all. Right, so now we can say, okay, this is order number one for customer number one. Date is 3/9. Thanks, Excel, whether or not it's paid or not. And you might even want an order total here, right? Again, a couple different ways here. Some people think wow, that wasn't even close here. Order total. What was I doing? You could just sum that from your order item, but then you have to do a lot of arithmetic if you'll be like, hey, what is the average order here? Are my customers spending a lot of money or a little bit of money here? And how do I make them spend more money? Right? So some things we double here just to make our arithmetic easier. That's a trade-off. It's okay. But now, okay, so now for order number, this is supposed to be 1, 2, 3, whatever here, right? It'll just autofill. Excel can do that for me. Right? Order one for product one, product two. Maybe I wanted two of the widgets. Maybe I wanted three of the gaskets here. That was $2.50 at the time. This one was, I don't know, $3 at the time. I forget what it was here. So I can have n number of order items here for a single order. So when we start talking about databases, we think about how these tables relate to each other, right? Sometimes it's a one-to-one relationship. This table will relate to one of these things, and one of these things will relate to one of these things. That's not super common. Most time we get a one-to-many. Right? One of these things will relate to many of these things, but of the many things, they only relate back to one of the main things. So we'll have one order with many order items. Every order item relates to one order. Okay, so we can walk that back here, right? One product will relate to many order items, right? But one order item just relates to one product, right? One order relates to one customer, but a customer can have many orders. Ideally, you get your customers to come back, right? They'll have many orders in the system, these sorts of things here. So we think about all these relationships. So anytime we have this many and many relationship, we can't actually do that, right? So we need to break it into a one-to-many and a one-to-many. We make these joining tables here, right? So you can't have many items in your order. You have to have many order items, right? Because we want many people to order many products. That was our first relationship. We can't do many to many. We said, okay, well, let's have an order here. Well, you still can't have many products in one order. So now we had to break that into our order item here. So that relates the one-to-one here. So we'll just have lots of entries here. So we build all that out here so we can add information to our database here, to our tables, and they can reference where these other things go, all the details of the other pieces of information for us here. Databases are good at this sort of thing here, and our relational database management systems will enforce our referential integrity to make sure, hey, if you told me this is an order ID, it has to exist in the order table or I'm going to puke on you. You can't give me an order number that doesn't exist because there's no referential integrity there. And I'd be in a bad state here. I don't have anything that exists there. You can't tell me you want product number 57 if you don't have product number 57. Right? You can't bill this to customer 22 if you don't have a customer 22. Right? We depend on having referential integrity because you have to be able to go look up that information. We didn't duplicate it. We didn't copy it into my table here. So I have to be able to go look it up from somewhere. So we depend on that to work so that all of our connections here will work for us. So we can build out our databases with our rows and our columns, right? Rows and columns, attributes and tuples, whatever you want to call them here. The SQLite browser is pretty cool. PyCharm has a built-in tool, but I think you have to pay for premium for it. It's been a little while, and they keep changing it on me here, where it can open up SQLite databases. You can just go get the browser, and that's this other tool you can use for free all the time here. I think I have it installed, don't I? SQLite browser. Oh, I might not right now. That's okay. Um, so other sorts of fun commands, you just add the SQLite library here as we're going. So we'll import our SQLite library. And here, we'll just steal his code for a second here. Why not? Oh, that's the wrong page there. There we go. And then let's mention we're getting it from Dr. Chuck here. So we should cite our sources. Right? So it says, hey, let's go connect to this SQLite file here. Again, this is using relative file paths for now. Not the end of the world. Absolute paths are going to be a mess for anything shared, right? Because you probably don't all have the same user folder, that sort of thing. It creates the connection here. I don't know why he doesn't use the full word here. That's okay. He drives me nuts sometimes. And then cur, you can run SQL commands. So these are SQL commands here that go and do some things. So we have two sort of flavors of SQL commands. I don't know if you've done database stuff before. This is really boring. My apologies. If you haven't done database stuff before, it's going to feel like we're covering way too much. Again, sorry. We're just trying to get you enough so you can get up and running here. You get data manipulation language, the DML, that's inserts, updates, deletes, and selects. That's my CRUD operations. You can create, you can read, you can update, you can delete data. That's manipulating the data. That's our DML. And you also have DDL, our data definition language variety, that sets up the structure, that creates the tables, it drops tables, it adds columns, those sorts of things. It's how do I set up the structure here, not manipulate the data within it. Right? Well, it sounds really fancy. It's okay. Don't worry too much about it here. But we need to set up our table here. So this is saying, okay, if I have a table, get rid of it. I'm going to start one from scratch here, and it's going to have two columns. So this table called track will have a title column that's done in text here, and I'll have a plays column that's an integer. Now, SQLite only gives us a couple data types here, right? We get, where does it go here? Integers here. Wow. Blobs for like binary data here. Chars or text is probably the easiest one here. Yeah, I think it's all the numeric ones here. Type lists, there we go. That's a fun one here. It's a little weird when you do build our tables. You don't have to tell it the types. Usually we want to tell it the types here. Um, it's made to be quick and portable and easy. Essentially, you get text, you get numbers, and the blobs. About the only thing we're going to store. Um, Dealing with dates and times is a big pain. Usually you'll store those as the numeric value. You can store it as text, but it's not comparable at all. So dealing with dates. And SQLite is not great, but it's quick and easy, right? The real major database management systems here, you can store everything distinctly, and it's fantastic. And we'll make the table. So this goes and sets us up with a file here, and now we have a SQLite file. The file didn't exist before. Now it did. We created it right with our create here. Or setting up a connection will go make that for us. It's empty. I don't think um, there was a way to open it here. I guess not in this one. That's fine. If we can get that SQLite browser. What did I use before? Hmm. Download. Oh, I just had I think I just used the standalone, the no installer. That's what it was. Yeah, I've downloaded this twice now, or 3 times now. There we go. Let's extract that. All right, DB browser. It's a little portable application. We'll go point it at a database. Now you can build your own database in the SQLite browser. I like doing it here because then I don't have to write all the Python commands. And most of the time you don't want to drop your database and drop your tables. This gets to be a little ugly, and this will crash on you if the table does exist. So building it here is pretty nice, but that's fine. We'll just go open our database. So let's go find it in our documents in GitHub, CIS 298 in the week 8 or week 9 databases. Here's the SQLite file. It says, hey, it found one table. It has a track table. It has a title and it has plays. Right, so we can explore, we can browse this database here in the SQLite browser, here, which is pretty cool. If you want, you can make more tables, right? So instead of going through and doing it, oh, I followed the link here. Thanks. PY4E. Got off of it here. Instead of making all of your commands here, right, having to go set up all your tables. Does he only do the one? Yeah, multiple tables. Tracks here, um, artists. We could go build it out rather than writing all the code here. Right? If you don't like writing the SQL code to create tables, you don't have to write it yourself. You can use the tool to click and drag or click point, those sorts of things here. So we can make a table for name, eyes. Why do we want to know what color their eyes are? Dr. Chuck's a little interesting. Sorry, he's smarter than I am, so he can do whatever he wants. So then artists, again, will make that ID, their integer, their unique name here, unique identifier for it, tracks, artist ID. So now we need to add the artist ID to our track here to know who's the artist for that track, right? Whatever that ID is here. So we'll go add in the artist table. Just here, we can add some fields then. What's the field? This is an ID here. And right in the SQLite browser, we want it to be a primary key here. This is the unique identifier. And we want the auto increment. This is not artificial intelligence. This is auto increment. Yes, you can turn it on and not feel bad about yourself. It's okay. So it says, hey, this is a primary key. Let's auto increment. As we add something, just give me another number, give me another number, give me another number. This is easy for us here. And then we can add the name here as here's my type, right? Oh yeah, so numbers of decimal places are numerics here. I forget what real is, but text. The NN is for not null here. If you want someone to be able to give you a null value, don't check not null. If you do check not null, they can't give you a null value. They have to give you something. Generally, nulls are really ugly here, but again, for SQLite, it's not worth a whole lot of time, energy, and effort. And you can also check the U for unique. You can have other columns that should be unique here to be unique identifiers. Like when they entered your information in the system, they probably got your social security number. That's unique, but they're not going to put that all over your student ID card. Right? So there might be a unique field but not your primary identifier. There's other things you can do with stuff like that. Right, so we got name, and then I guess eye color. Sure, eyes as the text field here. Sure. We'll say, okay, let's make the table. So you could just copy paste this then into Python if you wanted, right? It's showing you what it's going to run, or you just say, okay, and it goes and creates it here, right? You can always go get that data back out later, which is cool. So we got our field here. Now then track, we had to go and update. We had to go modify our table here. Yeah, save our changes. Let's go add a artist ID. Artist ID as an integer here. And this is a foreign key here. So it relates to artist, the ID field. Now, this one here is a little bit ugly. I don't think it can change right now, but that's okay. There's that idea. Sorry, I clicked over it really fast. Where did it go? Did I not hit save? Artist ID? I hit OK, didn't I? Must not have saved it. This foreign key clause. What do I want to do if it updates or deletes? So can I delete an artist from the artist table if it has tracks that relate to that artist? So the two options you have are no, don't let it delete because that would break referential integrity, or sure, let it delete and then cascade that delete. Just delete everything that referenced that ever. Sounds really scary. No one should ever turn that on ever. It's a terrible option. Yeah.
I think it went away because you're actually from artist.
I'm on track. Oh no, because I wanted to reference artist ID for the track, I think. Um, cool. Maybe I just didn't hit. I think I got to hit save. I think it'd be there. Let's try it. Save now. Save database. That's an as. Huh. Now let's go. So let's go add a artist here then. So we'll go browse our data. I'm going to go add an artist. That's it. No, I want to add. I can not use SQLite browser in a little while. Sorry. I don't know if I can add from here. I thought we could add a new column. It's not letting me add to it. Shoot. That's all right. Then we can just see what's in it. All right. So we've got this. We don't actually need our connection here. I guess we'll comment this out here. We don't want it to delete the table every single time we run, right? We want to set the table up. Now it exists. So now my program can interact with the table and the data will stay there when we're done with it. So we can add in then some information about our artists here. Let's go. So this is our cursor, execute. And if we make that a double quote, I can get that all in one line here. Now, if we're auto incrementing our key, again, he didn't do that. It's okay. It's not the end of the world here. We don't need to give it an ID. You just say, hey, I'm going to give you the name and your value, your eye color here. We'll let the database do the auto increment. That's usually easiest here as we go. So we'll execute our query. One more set of parentheses. There we go. So we can run it. Now we've added Frank Sinatra to the database, so we should be able to go see him now when we browse our data. Artist, track. Did I do it wrong? Name and eyes. I must have done something wrong. Into, oh, it's not a capital A artist. I don't remember if it's case sensitive or not. Run. Runs our data. Just refresh. Come on. I have to close it and then open it again. Nothing. Oh, we never saved. Sorry. There we go. Commit. So we have to go and make sure we save it to the database. So tell it, hey, we added it, and please save this change. Use this commit, which is fun. You can do substitutions here. So instead of having to give it the values individually, you can do substitutions. This is really important if we're dealing with anything that comes outside of our code. So any sort of user-based input, or we're getting it from another source here. If I just string interpolate it right into my SQL command here, they could give me bad stuff. And there's this thing called a SQL injection attack that says, hey, I'm going to give you bad looking stuff here to throw into your SQL command. And if you run it, it will do bad things because you just took the text I gave you and threw it in. This has been a very well-known vulnerability forever here, and people still fall prey to it somehow. It makes me sad. So our tools then, if we're doing the right thing here, avoid that. So don't just throw it in here. So doing these substitutions here, I said, hey, I'm going to substitute in these question marks, these values here. It'll protect against that, which is nice. We'll do some quick sanity checking. But then we commit. There we go. When we're done. Now we can actually save our code or save the work that we did here. I should be able to go browse it here. Back in artist. There we go. And now we get Mr. Frank Sinatra. Or just Frank dot 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 apparently. There it goes, Sinatra. ID one. Right. But now every time I run it, I'm going to get another Frank Sinatra, another Frank Sinatra, another Frank Sinatra. So having inserts hard coded in is not really ideal here, but that's okay. It's just a quick little example here. We got a bunch of Franks. Right. If we're going to go delete these rows, here they're gone. What do you think the next ID number is going to be? Right, I just deleted through number 8 or 9. Is the next ID going to be 2? Because that's the next available number?
Not even decrement, right?
No, because I didn't decrement the auto increment. Yep. So it still remembered those ones used to exist here. So the next number will just be the next, because the SQLite database tracks that itself. It actually tracks it internally, which is kind of cool. So we just pull up the next one. Awesome. So we can go build out tables. We can interact with our tables. We can go get data from them here. Uh, on Wednesday, then we'll finish up a database example, and we can talk about the next project here. You'll go out and build a database you can interact with. We'll make it like a school registration database, since you're all super familiar with that, where you have lots of different pieces of information, lots of different tables to join here. And we just let a user, again, at the command line. It's not very interesting and exciting, but just some practice. We go add some data, update some data, read some data, run some reports, these sorts of things. Pretty quick here, but it'll get you some good practice working with databases. Should be a lot of fun, and then a good chance to make sure your teammates are going to be good for your final project. Okay, all right, sound good?
Yeah.
All right, awesome. I'll see you folks on Wednesday then.